I'm Peter Hall.
And I'm Christine Edwards.
We set up Sci-Tech Systems in 2003. We had an idea for a man overboard system. At the time we did a feasibility study and that proved successful, but we were a little bit ahead of the game. The equipment that we needed wasn't actually available for us to build the units. So the project has been quiescent until 2008. Now what happened in 2008 was that we entered the European Satellite Navigation Competition, and we done remarkably well, really. We won the UK prize, we won the GSA Special Topic Prize for using EGNOS, and we won the overall Galileo Masters competition. And that really turned the project around. It gave us a lot of visibility. People started listening to us rather than ignoring us, and it gave us the ability to develop our prototype and get to the point we're at now, where we have a working prototype which will track units in the water up to a distance of 2.2 nautical miles. That's about 4.5 kilometres. And now we need to miniaturise the device and get it to a stage where we can do a production run. If we were sailing now and someone fell off this boat, the best person, the best placed vessel to rescue them is this boat. And that's what our system is about. We know where the person is in the water, the boat knows where it is. We've got radio communications, two-way radio communications, and we modify the signals that we receive so as they'll feed into any standard navigation system and come up. So someone goes overboard, you've got them on their chart plotter or on a repeater out in the cockpit, and it's units that people are used to using. They don't have to learn anything new at the time of an emergency. Well, the idea is that the unit will just fit into a life jacket. The life jacket will automatically inflate if someone falls in the water. I think they need to be in the water about 5 seconds before this goes off. This unit will activate at the same time, and then once you've done the aided startup, which is only a few seconds, you're tracking the person in the water in real time. This is really what our original concept was. I mean, it's evolved a little bit since then, but the idea was that if it wasn't built into a life jacket, it could float free. The weight of the battery would make the unit float upright. So this is gimbaled. It will keep the antenna in the right orientation, and it can be tethered to the person using a little bit of cable.
The final unit will be about the size of a mobile phone, so you've got to get from this size down to this size.
This is our prototype board. Now it may look large, but if you look at it carefully, there's huge areas where there's no components, and also this has been designed to allow us to trial a number of different options, different power supplies, different antenna, and also to take off a lot of information that we need in our development of the product. The operational parts cover about a quarter of this board, so that gives you an idea of the first level of miniaturization, but we believe we can get it smaller than that. Well, the testing, we first of all proving our software, proving the hardware. We worked in the lab, then we took it out to the car park outside around Stevenage, where we were based at the time. We then moved on to testing in the water, tracking in the water, putting this prototype unit in the water, making sure that we could still communicate with it all right, seeing just how much the water affected the signals, and eventually tracking from 2 boats, the unit based on one boat, sometimes in the water, sometimes on the boat itself, and tracking it from the other boat, and to see how reliable it was, what affected it, if we could work with line of sight, or whether if we lost line of sight we could still work, and which we amazingly found that it does work.